Hey folks, welcome to Chapter 3, Section 1, Parallel Lines and Transversals. At the beginning of these notes I'm just going to go over a bunch of definitions and then we'll get into some examples after that. So the first thing to hit is the definition of parallel lines. You should be familiar with what parallel lines are at this point. They're coplanar lines that do not intersect, right? So from an algebra standpoint, it's the same slope, and they'll never touch if they have the same slope. Uh, if they have these little triangles, if you're looking at like a figure, and they have the little triangles or the little arrows, I guess I should say, um, those will be used to indicate that lines are parallel. Okay, so be on the lookout for that in the future. Skew lines I've covered briefly. Those are they're non-parallel lines, but they don't intersect um, because they're non-coplanar. Okay, so wait, yeah, non-coplanar. So they're in different planes, so they can't possibly touch each other. Um, and then parallel planes would be something like plane A here and plane B there, planes that do not intersect. Okay. And then it might seem kind of obvious, but it's worth mentioning. If segments or rays are contained within lines that are parallel or skew, then those segments or rays are also parallel or skew. Okay? Now let's talk about what a transversal is. Um, so a transversal is basically a line that goes through a couple of other lines. So the definition is it's a line that intersects two or more coplanar lines at two different points. And so in the diagram below, notice that line T is a transversal line that intersects lines Q and R, creating 8 different angles. Okay, so here's the picture. Here's my transversal T intersecting Q and R. So I have some terms to go over with you right now. First off, let's talk about what is an interior angle and what's an exterior angle. So you'll see everything marked in the green here as interior. I like to think of the interior as the mouth of the angle. You can also consider it as the middle, like in the middle between the two lines. Um, and then the exterior is simply everything outside of the mouth or outside of the middle. Okay. Um, then we have these 4 terms to go over: consecutive interior, alternate exterior, and corresponding angles. Okay, so let's go with consecutive interior first. Consecutive interior means um, you have these angles. You can go from 4 to 5 without skipping over any other angles or skipping over any lines. Okay, so 4 and 5 are consecutive interior angles. 3 and 6 are consecutive interior angles. And those are the only 2 examples of consecutive interior. I wouldn't say 4 and 3 because they're skipping over the transversal. Okay, those would be considered adjacent angles. Okay, same thing with 5 and 6. So it has to just go from one to the other. They're I don't know, like next to each other, but you're not skipping over any lines or any angles to get to them. That's why you don't see any consecutive exterior angles, because 1 and 2, again, you're skipping over the transversal T there, and then you'd have to skip over angles 4 and 5 to get to the next exterior angle 8. So that's consecutive interior. Okay, the next one that is mentioned is alternate interior angles. So alternate interior angles are ones that are inside, yeah, but they go on opposite sides of the transversal. So you might be tempted to say, oh, 3 and 4 are alternate interior. No, those are still just adjacent, okay? You could argue that they're adjacent interior, um, but that's not one of the terms we're learning here. So 3 and 5 are alternate interior, and 4 and 6 are alternate interior, okay? So it's got to skip over the transversal, and then you got to like go up or down, like go to the opposite one, so to speak, okay? So 3 and 5 alternate interior, 4 and 6 alternate interior. The next thing to go over is alternate exterior. So you're going to be looking at like angle 1, and then again, this is adjacent, so you're going to skip all the way down here to angle 7. So you'll like go to the other side of the transversal, and that's your alternate exterior, 1 and 7 or 2 and 8. Okay, it's the same kind of pattern as alternate interior. just now you're on the outside. That's what alternate exterior is. Okay? And then the last thing to cover is corresponding angles. Corresponding angles are one on the outside and one on the inside. But specifically, it's skipping over the one it's adjacent to. So 1 and 4 are still adjacent angles. I know one's interior and one's exterior, but they're not corresponding if they're adjacent. Okay, corresponding is angle 1 and angle 5. Other examples of corresponding would be 2 and 6, 3 and 7, and 4 and 8. Okay, so corresponding has to be on the same side of that transversal, and then it's skipping from outside to inside or inside to outside. But yeah, I think so. Covered interior and exterior, and then yeah, checked off consecutive, alternate, interior, exterior, and corresponding. So yeah, let's get into some examples here. Alright, so example 1 says identify each of the following using the wedge of cheese shown below. Identify all segments parallel to JP. So remember, they are non-intersecting coplanar lines. So JP is on the same plane as KQ, and JP is on a different plane, but they're still the same plane as LR. They're the walls of the wedge of cheese. So yeah, KQ and LR, remember order doesn't matter, so you could say QK and RL if you wanted to. Letter B says identify a segment skew to KL. I identified all skew segments. So remember, skew is non-intersecting and it's also non-coplanar. So here's KL. QR would be parallel to that, and then anything that intersects with KL is not an option. So RL, QK, JK, JL, those are not the answer. They're going in different directions, but they're intersecting, they're touching, they're meeting with one of the endpoints of the line, so they can't possibly be skew. So you want to look at something going in a different direction, like JP here, that's clearly not touching the segment of KL. PQ, same thing, going in a different direction, but not touching KL at all. And PR, different direction, not touching KL at all. So those would be some good skew examples right there. And then lastly, identify a plane parallel to PQR. PQR is just the bottom face of this wedge, so we look at the top of it. JKL, excuse me. Any of these three letters in that order, or any order of those three letters would be acceptable. Alright, example 2, we're going to refer to the image below and classify the relationship between the pair of angles as alternate interior, alternate exterior, corresponding, and consecutive interior, and then I abbreviated them as such. So angles 1 and 5, this is on the outside. So, well, let's first go over what's inside and outside. This is interior, 2, 7, 3, and 6. This is like the mouth of the angle, or the middle in between the two lines. And then 1 and 8, 4 and 5 would be exterior, okay? So angles 1 and 5 skip over the transversal, that makes them alternate exterior. Looking at letter B, 6 and 7, they are on the same side of the transversal and both interior, so that makes them consecutive interior. 2 and 4, here's 2 here, inside, here's 4 there, outside. They're on the same side of the transversal, so that makes them corresponding. Corresponding angles do not skip over the transversal. Like 2 is not corresponding to 5, or like 1 is not corresponding to 6. You don't see that. That's not one of our vocabulary terms. To my knowledge, there isn't a vocabulary term for something like angles 1 and 6 or 2 and 5. Okay, if anybody was thinking about that while watching this. So angles 2 and 6. Let's get back to this. 2's here, inside, 6 is there, inside, and they skip over the transversal. That makes them alternate interior angles, okay? Example 3 is the same thing. We're going to classify them, just a different image. So this is still going to be the interior. I know you have one line going straight up and down, and this is very much a diagonal line. So it doesn't quite have like a mouth, so to speak, like a Pac-Man style mouth. But yeah, 3, 8, 2, and 5 are still interior. 1 and 4, 6 and 7 are exterior. So angles 2 and 6, here's 2, here's 6. One's inside, one's outside, and they're on the same side of the transversal. That makes them corresponding. Angles 1 and 7, 1 is outside, 7's outside as well. On opposite sides of the transversal, that makes them alternate exterior angles. Angles 3 and 8 are both inside, and they're not skipping over anything, so this makes them consecutive interior angles. And then angles 3 and 5. Here's 3, here's 5, both on the inside, but skipping over that transversal line C, so that makes them alternating interior angles. So, example 4, the driveways at a bus station are shown. Identify the transversal connecting each pair of angles in the figure, then classify the relationship between each pair of angles. So, we have angle 1 and angle 2. Here's angle 1, here's angle 2. So, the sides of their angles would be line X and line S, and the transversal going through it would be line V. And so, since 1 is on the outside, because you can clearly see 1 on the outside and 2's on the inside here, that would make them corresponding angles. So I just put a C, like I did for the other ones. So angles 2 and 3, that one's kind of weird because it's hard to tell where the 3 is. It looks like 3 is tucked in this corner, but you could also argue that it's in this corner. Personally, I think it's in this one. So I just put two answers. My first answer, the one with line V, that's where if 3 is tucked up here. Because line X and line S would still be the walls of my angles, and then line V would still be the transversal. That makes this that makes these alternate interior angles. They both would be on the inside because they're both in between X and S, but they're skipping over the transversal line V. But if you said angle 3 was over here in the bottom corner, bottom left, then you would just kind of remove line V because it doesn't have anything to do with this scenario, and line W would be the transversal. So X and S would still be the walls or the sides of the angle, but line V no longer has anything to do with it. And so if line W is the transversal, then they're both on the same side of the transversal. They're just going to become consecutive interior angles. They're both on the inside because they're still on the inside of X and S. Okay, they're just not skipping over the transversal line W. So that's why I have two answers there. And then the last example is 4 and 5. I used line Y. I said line Y was the transversal because here it is. Line T would be the wall or the side of angle 5, and then line W would be the wall or the side of angle 4. So you can clearly see they're both interior angles because of that, and they're both on the same side of that transversal, making them consecutive interior angles. So I hope these examples helped. I hope you learned something. Thanks for watching, and goodbye.